I extend my greetings to all the panelists and all the listeners, and sorry for not being there due to my schedule. So today, I would like to briefly inform you about Baykar and the technologies that we provide. Actually, I am the CEO of Baykar. Baykar is a dedicated unmanned aerial systems developer and manufacturer company based in Turkey. And Baykar, as of now, in the last 20 years, depending on our heavy investment, we have become the significant player in the aviation and defense industry, focusing on unmanned systems. Unmanned systems are really paradigm-shifting technologies in the field of aerospace, and they have become the key force multiplier elements on the warfare arena specifically, but as well in the civilian areas, you see a significant upward trend. And our solutions are based on military and civilian applications, and we have a dedicated 2,700 people. About half of them are engineers from various disciplines, and the rest is the technicians. When you look at specifically the Turkish military industry, Turkey has embarked on self-sufficiency. Turkey focuses on native technologies, and in the last 20 years, there are huge investments based on national development programs. Turkey used to use before in the 1990s, Turkey was directly procuring these technologies from US or from Israel. But we as a nation, we faced a lot of challenges. And due to these challenges, Turkey politically made a decision that we will be self-sufficient in this industry, in this technology. And this is 15 years back. And with these national programs, all the results that you see right now on the world are depending on that decision. So we were solely dependent on foreign technologies, but then we faced a lot of limitations, and these limitations made us embark on these technologies, make up R&D teams. I would like to move on with my presentation. So these are the results. These are the results of the Turkish national programs. So we were facing challenges. We made a decision to be self-sufficient on these technologies, and these are the results of it. So we as Baykar, we started very small size platforms. As you see on the screen, we have a variety of range and operational altitude, different platforms doing different missions. And you see on the left hand the small scale, and then tactical, and then strategic, and the unmanned fighter one. Bayraktar TB2 has become really world-renowned product because it has been exported to 24 different countries. It's the tactical class platform, which is very flexible and easy to operate, easy to set up, and it's a very effective. When you compare the price to performance ratio of the system, it's really a very attractive product. We have delivered more than 400 units, and we have accumulated more than 500,000 flight hours with this platform in the last 6 years, which is a huge experience actually. And these are the system elements. You might think of it as it's not only an air platform, but it's a network of systems. And it is these elements that makes it really successful. When it is tactical class, one of the most critical thing is the reliability of the platform. So all of the subsystems which are flight critical and which are mainly the software and electronic elements are in-house tailor-made items. And by the way, all of this, the subsystems are export-controlled items. It's not possible for a company in Turkey to acquire and procure this substance. So we have to develop them. And in order for them to perform in the best way, you really need to make it tailor-made so that the platform becomes reliable. It's not only military environment. We are as well servicing Turkish forestry. Every year we are in the 4 months summer season, we fly heavily to detect forest fires, and it helps radically. Shortens the time to detect the fire, shortens the time to take action against it. And then our another flagship product, which is operational and which is in serial production, is Bayraktar Akıncı. It's a turbine engine powered platform, 6-ton takeoff weight, and it can carry about 1,500 kilograms of payload, and it can fly up to 20 hours, and it can go up to 45,000 feet. All of these numbers that I'm putting are proven by flights. So, and it can carry a variety of smart munitions, standoff weapons, and also indigenous ELINT, SIGINT, electronic warfare suits. As TB2, we have developed a lot of avionics and electronics to make this platform come to reality, and you see the main basic elements of the system. So it's not only the platforms or the ground systems, you really need to have a solid wireless communication on air, and also wired or wireless communication on the ground side, where you need to disseminate all of the information that you are gathering to the decision makers. On that regard, we have a lot of software, network-based software systems on the ground side to make this system more effective as well. And also, we as Baykar, we believe in the future of the flying cars. It's the coming revolution, like electric autonomous automobile. This is the next revolution. So we started investing in it. We have a Jezeri flying car project where we mainly focus on the artificial intelligence guidance and assisted guidance and control systems. We did our first flight last year with it, and now it's on experimental phase, but we are heavily investing on it, as it will be in our lives in the near future. And also, we believe the future of the military aerospace is on unmanned systems. Then unmanned fighters will take their place there. So we have a project named Kızıl Elma, Bayraktar Kızıl Elma. It means golden apple. In Turkish tradition, it means a target that you can never achieve. It's a target that you can never achieve. This project is right now on testing phase. It's a 6-ton turbo fan powered jet platform with fully autonomous features, equipped with low radar signature, with indoor base, and as well as indigenous radar and electro-optical targeting systems. So this, and also with its national indigenous weapons and standoff weapons. We aim to fly this platform very soon. In the coming 3 to 6 months, we will have its maiden flight. And also, this platform will have the capability to land on landing platform dock ship, which is the Turkish-made product, which will be in service after 1 year. We have another product named Bayraktar TB3 as well, which will be capable on autonomously landing and takeoff on this big ship. So these are the main elements of our research and development and manufacturing. And there's really a huge change on the field when you look at the military warfare arena. It was before Homeland Security, peace enforcement. The air defense threat levels were low to medium, and the jamming electronic warfare environments were medium. But as of now, you see unmanned systems being used in conventional warfare environments. And the environments are heavily jammed, and the air defense threat levels are high. So the capabilities and the requirements are as well. It needs to make you to come up solutions to these challenges, and there is a trend on the future. This will be much higher. You need highly maneuverable, aggressively maneuvering, air-to-air engaging, and high speed, high altitude. Different requirements are there, and these need to be fulfilled. So when you look at the basic scenario of how a Bayraktar TB2 used, you see a typical scenario. So you have the ground elements, and all these ground elements are connected to each other through fiber optic or wireless networks, whether it be a command center, whether it be a headquarters or the remote stations. And then you have a fleet of UAVs, and where this fleet is managed on the ground, and also you benefit from the satellite communication systems, and UAVs are flying day and night, and you can use them on the risky environments. You can risk them, and when you define a target, you can precisely engage with them. So this is a typical scenario how Bayraktar TB2 is used on the field actually, and then with the Akıncı, with the Akıncı and the unmanned fighters, the scenarios are becoming more complicated. So it's not only air-to-ground missions, but as well you might engage with air-to-air missions, and you will have more electronic warfare payloads to be equipped with, and it's becoming more complicated. And all this missions you really need as well AI, artificial intelligence developments to assist the system to make its own decisions. So right now it's the operators, the payload operators, the pilot operators on the ground who are making the decisions. There's an autonomy with the UAV, but with AI, this autonomy level is you switch more to the airborne side, and you keep it low on the ground side, and it's coming day by day actually. So this is I think I am done 15 minutes, and this is my brief presentations and the capabilities that we have on this field. So thank you very much for listening.
It's a pleasure for me to be back in Korea, and I would like to illustrate the man-unmanned teaming concept with something which we do at Airbus right now, and already since the past few years for the coming decades, which is the Future Combat Air System, FCAS, and which will, we believe, be the key to ensure operational and technological sovereignty for the decades to come. So within FCAS, again, Future Combat Air System, the next generation weapon system will be the most important European defense program for the next decades. This is more than just a new fighter. It is a network-based, information collaborative system with fighters teaming with unmanned drones called remote carriers, orchestrated through a combat cloud. So Airbus is the European leader company that covers actually the entire product and component portfolio required by FCAS, from fighter till UAS, passing through space application and connectivity, as well as C4ISR type of applications. However, we know that to build the European system, we will require to have a high level of industrial collaboration with partners, other industrial partners in Europe, including also with governments, in order to have a fair and balanced work share and governance. So I would like to illustrate first with the first video what is this concept of system and systems.
The future, more complex, more dangerous, with faster spreading technologies. While blue nations safeguard peace and democracy, the rogue red forces have repeatedly attacked blue sovereign interests. In response, the blue nations decide to use air power to halt the red attacks. As part of the initial campaign, the blue air forces are tasked to neutralize a mobile red command and control center, which is undercover and well protected. Several platforms are sent out to capture live data from the operational theater. In the air combat cloud, the newly acquired information is merged with real-time intelligence and processed to ensure actual situational awareness and decisional superiority. The air combat cloud provides an actionable picture. The blue theater commander is tasked to suppress their integrated air defense system and neutralize their C2. The air combat cloud maintains an up-to-date picture which provides information superiority. Mission planning is initiated. data residing in the air combat cloud, coupled with warfare analytics, supports the mission planning. The most effective blue platforms are recommended and selected by the blue theater commander, who also validates the red targets to be engaged. The future combat air system package for this mission is now available. The combined network capabilities of the selected platforms will bring the blue air power to the next level. Large remote carriers are deployed by the A400M and team up with the new generation fighters. Collaboration results in multiplied power. Information from the FCAS platforms is shared, merged, and processed instantaneously in the air combat cloud, enhancing collaborative early warning, jamming, and firing capabilities. The warfare analytics present different engagement options supplied by the air combat cloud. These are constantly updated. Fully informed, a mission commander aboard one of the new generation fighters decides to neutralize a barrier of SAMs using the large remote carriers and their effectors. Within a synchronized 30-second window, all effectors reach their assigned targets. The air combat cloud supports an immediate battle damage assessment which confirms the success of the attack. The two Eurofighters launch their large remote carriers to neutralize the remaining threats. With the integrated air defense system taken out, the new generation fighters continuously track the target and are ready to engage. Red hackers penetrate the blue air combat cloud and cause a temporary degradation of the communication with the blue central C2. The resilience of the air combat cloud, combined with the NGF's battle management capabilities, allows the mission to continue. C2 responsibilities are distributed to the NGF mission commander. The NGFs release their own RCs. Optimizing the use of sensors across platforms allows the NGFs to detect the mobile SAMs protecting the Red C2. The threats are suppressed through active jamming and effectors. The way is now clear for the NGFs to take out the Red C2. The attack only lasted a couple of minutes. Immediately afterwards, multi-sensor data is fed back to the air combat cloud, which supports a first battle damage assessment. The destruction of the targets is confirmed. Following the destruction of the Red SAMs and C2, the airborne Red fighters maneuver towards the attacked sites. The incoming threat is identified by the NGF's passive sensors. Flying as a tight formation, the Red fighters seek to hide their strength from the NGFs. The small RCs maneuver towards the Red fighters, spoofing the shape of the NGFs and forcing them to break formation in order to distinguish them more easily. Both sides exchange a volley of air-to-air missiles. The fooled Red fighters wrongly target the small RC. An incoming Red missile is neutralized by the NGF's laser defense system. With the Red threat eliminated, the NGFs can now fly back safely. The air combat cloud has played a crucial role throughout the entire mission. It is now enhanced with data from the mission just completed, dramatically improving the post-mission management. Dominating the future battle space. This is FCAS.
So as we have seen in this video, in order to handle complex and contested environment, we need a system-of-system approach. And this is what we do at FCAS. As you can see in the core of FCAS, we have a next-generation weapon system, which is supplemented by actually a collaborative approach by complementing by existing air platforms for the operation nations. And this system-of-system approach, of course, will extend to further air platforms with the allies. So all of this is enabled by the multi-domain combat cloud, which is here to connect the various platforms and which we will act as a network of nodes to be actioned whenever needed. So this goes far beyond the notion of data links, as we will see on the coming slide. So We were used to have in the past radars, jammers, missiles, formally hosted into a fighter, a specific platform such as a fighter. What we foresee for the future is a distributed I would say, sensing, effectors, observation, and orientation nodes within the remote carriers, which will be all interconnected. And this is in this distributed approach that the system will be able to be more rapid and efficient. So we'll have observation node which will collaborate across and cross the shared information in order to communicate with the orientation nodes, which will build the actionable picture and the situation awareness. And based on this, then the decision nodes with human in or on the loop will then take decision with effectors, which will be the actionable and action nodes. So we will take a closer look now to the teaming of this new generation fighter and the remote carriers. The main goal is to enhance mission effectiveness, efficiency, and survivability, and employ the remote carriers as force multipliers in such a way that they will complement each other in a very scalable and flexible manner. And that will then make this new generation fighter effective and efficient. Remote carriers will be a family of drones, unmanned platforms, which can range from 200 kg up to 2 tons or even bigger, such as a Royal Wingman. Come back to the conclusion. So, as you have seen in this video, remote carriers are clearly establishing a new operational dimension, being part of FCAS in terms of mission effectiveness, efficiency, and survivability. It is a long journey. We have already started this journey back 3 years ago, actually. And what you have seen in this video as well, the F-1M launching some remote carrier drones, is something that we have actually done also very recently, 3 months ago. So you can, it's available in the public domain in YouTube, so you can also see that next step already done. We are looking forward to move into the next phase in collaboration with our partners in order to establish this European sovereign project. What I would like also to highlight here is the fact that thanks to the modular design of the solution, we will envisage partnership with nations and industries outside of Europe. South Korea has been and is a very important partner for us in Asia Pacific. And definitely we are open to discussion to see where we can bring value with the industry and with the government into the future concept, such as the future combat aircraft system. Thanks a lot for your attention. Open for questions.
Thank you. Thank you very much. Johan mentioned that future combat air systems and the next generation weapon systems related to European future programs. In Korea, we have the same stance that we need a high level of cross-industry cooperation between all partners with a fair and balanced work share and governance to develop new cutting-edge technology weapon systems. I have 2 questions to you. Okay, thank you very much. And first question is that what could be an optimal industrial model to build the future warfare system, given the system of systems? My second question is that should there be a leading company, or would it be better to have an under industrial consortium? Thank you.
Thanks a lot for the question. So, first of all, I think to build a system of systems, it's complicated to have only one company able to master all those technologies. So we really believe in collaboration. That's the approach that we have taken in Europe. Airbus is obviously a leader in those technologies, but we have been used to collaborate with other industries in Europe in order to build complex programs. And this is exactly the same approach for this system of systems. Just to elaborate a little bit more, the FCAS is today a 3-nation program with France, Germany, and Spain. And they have actually allocated per nation a prime industry leader. And then in accordance to the FCAS concept of system, we have also some technology leaders per domain, example, fighters is in between Airbus and Dassault. Then we have the engine, we have the combat cloud. On this one, Airbus is leading, but we have 2 other companies in Europe part of the story. So that's how we have taken the approach. That answers also the second questions in terms of who shall be prime, who shall lead. So in the FCAS, we are not yet at a point of a contract for implementation of the system itself. But we have some industry leaders per nation to develop the various building blocks. And again, if you do that at the level of a country, I think what is important is to organize your various national industries, how they can build such a system of system. And we at Airbus, we are always willing to collaborate with some building blocks, modular approach, but at the end of the day, it will be a sovereign system that you are probably building.
Okay, thank you very much.